Hello everyone. So now I'm going to talk a little bit more about vectors, how they work. So let's say you create a vector and by default, let's say it has some size. So in the STL vector, this size is actually 0. But let us assume you have a vector of, let's say, size 4. That means the array can accommodate up to 4 elements. So let's say 1, 2, 3, 4. So now you want to insert one more element in this vector, that is 5. So what this vector will do, it will double itself. Okay, so it is going to double itself. So what is going to happen actually is uh, a new vector, a new array would be created at some other part of the memory. Let's say this location is 100, and maybe at some other location, let's say 760, a new array is created, and let's say this array has a size 8. Okay, so what I'm trying to tell you is, if the original size of the vector is x, then the new size would be 2x, and this is a dynamic array. This memory can be freed up. So this vector will copy all the elements from the previous location into the new location, and it will also insert 5 at this particular location. Okay, so this is what this is how the vector actually grows itself. Okay, and once the new vector is created and the old elements have been copied, this array is deleted. Okay, so the memory is freed up, and this is where the new vector is. Okay, so all of this can happen automatically if you use the container class that is provided by the STL. If you don't use it, then we have to build this functionality in our own vector class. Now suppose you keep on inserting more elements, let's say 6, 7, 8. Now again it is full, it will again double itself, and you will see the size of the vector is now 16. It can store up to 16 elements. Okay, again this size will become 2x, or let's say 4x. Okay, so every time the vector is going to get full, it is going to double itself. Okay, and this doubling helps the vector to accommodate more elements and grow in size. So what would be the complexity of pushing an element to a vector? Okay, so if you do push back, that means I'm pushing an element to the end of the vector. So for most operations it is going to be order 1, but in some cases it is going to be order of n as well, because you are going to copy all these n elements here, which is going to take order n time. Then you are going to insert 9 in the vector. Okay, so that's why it's going to be order n in some cases. But what we can do, we can find out the average time complexity or the amortized time complexity on an average, how much it is going to take. Okay, for every insertion. Okay, so now you can also reduce this doubling by, if you know that you are going to get at least 1000 elements. So what it is preferred is, you initialize your vector with 1000 boxes, and then if 1000 exceeds, only then you double. Okay, so that means if your data is going to contain 1500 elements, only one time you are going to double and order on operation for 1000 elements. Okay, so you're doing order n work once for n elements. That means on an average, for one element you are just going to do n upon n, that is like order 1 work. Okay, so on an average the pushing is going to still work in order 1 time. Or what you can do is, you can okay, so what I'm trying to show you is, there is this website c++.com, and this has a very nice documentation about all the STL containers that we are going to use. So if you're confused about some function or some data structure, you can definitely look up at this documentation. For example, I want to look at the pushback function of a vector. So it tells us this pushback function adds a new element to the end of the vector after the last element, and the value is copied to a new element. Okay, and this increases the container size by 1, which causes an automatic reallocation of the allocated space if and only if the new vector surpasses the current vector capacity. Okay, so as I said, the vector is going to contain two things. Let's say this is 1 2 3 4, so the capacity of the vector is 8, but the size, the number of elements is just 4. So once you exceed the capacity, only then the reallocation of memory is going to happen. Okay, and what is the so this is a demo we will see very soon. And what is the complexity of this pushback function? So you can see it is constant on an average, and reallocation may happen in some cases, and it is written if a reallocation happens, the reallocation itself is up to linear in the entire size. Okay, so I hope now you understood this fact. It's an important thing you understand why the reallocation happens and why it is taking linear time when it is doing a reallocation. Okay, but if you initialize it properly, the reallocation may not be that frequent, and you can say it is going to work in order 1 for most cases. So that's the whole idea, and this is little bit introduction about how vectors work, and next we will see the demo and then we will dive into the implementation. That's it. Thank you.